top of your page, it says that a midsegment is a segment joining the midpoints of two sides of a triangle. The midsegment of a triangle connects the midpoints of two sides. So like on your notes there, right under the word midpoint, what's the name of your triangle? ABC? And A is in the bottom left corner? Okay, so if we said that X was the midpoint of AC, then we would know that AX is congruent to XC. And let's put Y, the midpoint of BC, then CY and BY would be congruent, right? Okay. XY is your midsegment then. It's connecting the midpoints of two sides. If I threw Z down here so that it was the midpoint of AB, then YZ is a midpoint, or midsegment, excuse me, and XZ is a midsegment. So you really have three midsegments within a triangle. So you have three sides, so you have three midpoints. Yeah, it's a triangle within a triangle, which it actually makes like 4 triangles in there then. Okay. So a midsegment connects two midpoints. XY, YZ, and XZ, those are all midsegments. Below that triangle, you have your theorem for today, the Mid-Segment Theorem, which states, if a segment joins the midpoint of two sides of a triangle, then the segment is parallel to the third side and half its length. Okay. So looking at your triangle that we made there, XY is a midsegment. Since XY is a midsegment, then XY should be parallel to which side? AB, good. It's going to be parallel to the third side and half its length. So the length of XY is going to be 1/2 the length of AB. Midsegment is always parallel to the third side and half of that length. And you could say that for the other ones. You could say that XZ is parallel to BC and half of BC. Remember, when there's no symbol over it, that means length of. So let's pretend that the length of AB is 10. What would be the length of XY then? 5, good, because it's half of that. If AB is 100, what's XY? 50, good. If XY is 150, what would AB have to be? 300, excellent. So if you go from small to big, you double it. If you go big to small, you're going to cut it in half. Cool. Below your little theorem box there, it says blank is a midsegment of triangle ACD. Which of our segments is the midsegment in that picture? BE, good. And then add this to it. So turn your period into a comma, and then state, therefore, segment BE would be parallel to which segment? CD, good. And the length of BE equals what? Half of CD, good. The word of in math means what math operation? Multiplication. So when you say half of CD, you take 1/2 times that length. Good. Midsegment, parallel to the third side, half of its length. Cool. First little example there, or question, it says, in triangle DEF, A, B, and C are midpoints. We want to name all pairs of parallel segments. If A, B, and C are midpoints, then you can mark your picture showing that each side of the midpoint are congruent to each other. You know, like AE is congruent to AD, and CD is congruent to CF, and EB is congruent to FB. The worksheet. Okay, so we need to name pairs of parallel segments. Anyone have a pair of parallel segments in that picture? You guys agree that AB would be parallel to DF? Good, you should. So write that AB parallel to DF. Any other parallel segments, Micah? DA to CB. You guys agree? Technically yes, but no. Why wouldn't you agree? She says DE and BC, Micah. She says DE and BC. Okay. Would you agree with her? That makes more sense? But this one doesn't make sense, AD and BC? But wouldn't if it's parallel to the whole thing, wouldn't it be parallel to the half of it also? Right? We need another pair though, the other most obvious one that you guys are going to want to say. AC and what? One more time. BF. Okay, what's the more obvious one that comes from the theorem though? EF, good. Not that you're not correct, but yes, AC is parallel to EF. This one and this one and this one would be the ones that come from the theorem. You can go off of the theorem though and say like AC is parallel to BF then also because BF is part of EF. The three that I circled would follow straight from the theorem. Okay. So you have a bunch of parallel segments there. You also have a bunch that would be half of the other ones. So we're going to work with a little bit of that. So number 2 or 3, whatever number it is. I 1, you're 2.
Oh.
In triangle XYZ, MN and P are midpoints. So if MN and P are midpoints, then you would have the sides of the midpoints congruent to each other. So mark that down. It says that the perimeter of triangle MNP is 60. And then you don't have all these listed, but we're going to find them all. We need to find NP, YZ, XZ, and XY. I want to find all 4 of those. You only have 2 listed, but I want to find them all. Anyone come up with any answers? Okay, Spence, which one do you have? YZ would equal 44. What do you guys think? Yay or nay? Yay? You can't agree to your own thing.
Yes, I can.
Okay, somebody else. Trevor. XZ is 48. The rest of you, yay or nay? Yay, good job. Somebody else. Brian? XY, gotta find them, is 28. Yay or nay? Brian, how did you come up with 28? Oh. How'd you find NP? Why'd you subtract it from 60? Good. So you actually had to find NP first, right? Triangle MNP has a perimeter of 60. Remember, perimeter is the distance around. So all 3 of these need to add up to 60. So 24 and 22 gives us 46. 60 minus 46 would give us 14. Yay or nay for NP? Yay. Which then do you yay or nay for 28? All right, good. Last thing we have to find, the perimeter of triangle XYZ. How are we going to find the perimeter of triangle X? Okay, 8 plus 8 is 16, plus 4 more. Carry your 2. 2 plus 4 is 6, plus 4 more is 10, plus 2 more, 120. What, Brian, louder? Brian said he just doubled 60 and got 120. I mean, yeah, 60 times 2 is 120, but is that legal to do? Why? Why, Sam?
Because you like double all your other ones.
Yeah, so why not just double the perimeter, right? Yeah, good job. So let's pretend we had another triangle that connected the midpoints of these ones. What would be the perimeter of this little triangle? 30, good, because the perimeter of the middle one is 60. These are all midpoints, so they're half of it, so it'd be 30, and if we kept going, it would be
It gets
15. Yeah, okay.
Until it gets
Really complicated. All right, go ahead and do the next. Megan, did you figure out any of these answers? Which one did you get? Why? Okay, what's half of 18? Good. Good, this is your mid-segment, so it's going to be parallel to the third side and half of that length. Awesome. Lindsay, did you get either of the other two? Why? Yeah, because they weren't congruent. What's AC? Why? Yeah, what postulate is that? Yes, you do. What are you adding together? Yeah, but what are they? Angles or segments? So what postulate is that? Good job, Lindsay. You're using the segment addition postulate.
No.
All right, the bottom one. Find the measure of the following angles, VUZ and Z. See U, it's the midpoint of XZ, it's cutting it in half. And V is the midpoint of YZ. So what would you call this segment UV then? Called a mid-segment. And the theorem says that a mid-segment is what to the third side? No? Parallel, that's the one I'm looking for. So UV should be parallel to which side? XY. Okay, use that. See if that'll help you. Kendra, did you find the measure of angle VUZ? Why? Good. If the lines are parallel, then corresponding angles are congruent. So then VUZ would have to be 65. Kendra, did you find Z? How? Why? Good. So what theorem are you using there? No. Good. Triangle sum theorem. Yep. Good job. You knew it. That all three angles add up to 180, right?
Yeah.
Good. Okay. Questions on the front page. Needle, flip it over. Top one, we have to find the value of x, which is representing this outside length. I don't know if it copied very well, not so much here. Those two sides are congruent, so this little point would be a midpoint. And then on the right side, they're congruent, so we have another midpoint. So this segment that's a length of 5 is a mid-segment. It's going to be parallel to the third side and what its length? Half. Good. So if I use the words of the theorem, which says a mid-segment is half of its length, then 5 is half of the third side. That's how you would write it verbatim from the theorem. A mid-segment, 5, is equals half of means to multiply, the third side. How do I get rid of that 1/2? You could distribute, or I could also do what? Multiply by 2, because instead of dividing by a fraction, I can get rid of it by multiplying by its reciprocal, or the denominator. So when I multiply both sides by 2, then I get 10 equals x minus 11. How do I move my 1 over? X minus 1, how do you move your 1 over? 11, yeah, add it, and then you get what? Sorry, my brain was working faster there. Then you'd multiply by 3. Okay. Next one, you have 3 values to find x, y, and z. Ready? Do y and z. Go. Gracie, how should I find y? Why would you say that? Exactly. Good. The ones with the y's are equal to, or congruent to each other, so we'll set them equal. Did you get y to be 6? Did you check your work? What's 4 times 6? Plus one more. What's 6 times 6? Minus 11. All right. Taylor, what'd you do to find z? Y. Good. Did you get z to be 3? What's 3 times 3? Plus 5. How about 3 times 10? Minus 16. Good. Good. Yeah, okay, now we gotta find x. Set them equal, right? So we did with all the other ones. Why not? The mid-segment's half of the bottom one? All right, so how are we gonna write this then? Good. The mid-segment has to be half of the bottom length. So 2x is half of x plus 6. What do we want to do next to solve it for x? Yeah, you could distribute the 1/2 or multiply by 2. I'm a fan of multiplying by 2. So this would give you 4x equals x plus 6. Subtract x over. 3x equals 6. So what do we get for x then? 2. What's 2 plus 6? What's 2 times 2? Does that make sense? Okay. See how you can check your answers? Oh. All right, next one. The vertices of a triangle are A, B, and C. We have to find the midpoint of 2 of the segments and then decide if any segments are parallel. Let's graph them. Don't forget to label your points. It says it's the vertices of a triangle, so make them a triangle. And the first part tells us to find the midpoint of segment AB. How are we going to find that midpoint? Why do you giggle? Here's agree. Can we just count the midpoint? Okay. What's the midpoint of AB then? Well, we know it's got to be at -5, right? Because that's what the x value is, and it's not changing. You want to go -5, 5? Here's -5, 3. 5, 4. Okay, if you count it, well, like if you go back to elementary school, they probably tell you to count from both ends until you get to the middle, right? Or you can count the tick marks between. 1, 2, 3, 4, 5, 6. There's 6 between. So how many do we have to count each way then? 3. So if you go up 3, 1, 2, 3, and down 3, 1, 2, 3, you would be at -5, 4. There's your midpoint. How about AC? How come you're not giggling this time, Spencer? You can't count diagonal lines. You can't count distances. So then we have to use our midpoint formula. You have to find the average of the endpoints. Louder now. You said it quieter.
Oh, I did. X1 plus X2 over 2.
Good job. And then what? Good. Remember, average, you add everything up and divide by the number there are. So if I'm going to find the average of the endpoints, there's only 2 endpoints. That's why we divide by 2. So we're trying to find it for AC. So A is going to be my first point. C is going to be my second point. So when I plug them in, -5 plus 3 over 2, comma 1 plus 3 over 2. Simplify, what's -5 plus 3? -2 divided by 2. Good. 1 plus 3 divided by 2. 2. All right. -1, 2. So when I connect the midpoints, I get that mid-segment there. The last part says, is this mid-segment, the one I just drew in there, parallel to BC? Sí, bueno, it should be, right? Based off of the theorem. How can we double check? Since we're on a graph, how could we double check? Let's find the midpoint of BC. How else could we check if this line was parallel to this line on a graph? The slope. Would we want the slopes to be the same or different? The same, right? Because we don't want the lines to run into each other, so they have to be moving the same distance and da 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 da. Do you want to use the slope formula or count it? Good, you can count slope on a graph. So from B to C, I go down 1, 2, 3, 4, and then I go right 1, 2, 3, 4, 5, 6, 7, 8. So the slope of BC down 4, right 8 becomes what? No. -1/2, right? And then to find the slope of my new mid-segment here, I go down 1, 2, and I go right 4. What's -2 over 4 become? Negative, right? Because I went down. So are those lines parallel? Yeah. So we backed up our reasoning with our slopes. Questions on the graphs? Okay, the last 4 or 5, you have a bunch of them like this on your homework today. You only have one picture, and the information is going to change each time. So you might just want to follow along with me when I mark it so you don't have to continually erase it and stuff, but it's totally up to you. For this one, R, S, and T are midpoints. So I know that these things are congruent. Then it tells me that GH is 20. HI is 18. And we're supposed to find the length of RT. What do you think, Nick? For RT, how long is it? Well, they tell us that HG is 20, this far left side, and then the one on the right side is 18. We want to find this length right here. Why? Good. Yeah, it's got to be 9 because it's half of HI. It's half of the side it's parallel to. You don't want to cut half of what it's intersecting. Okay, part B. You have new information, so again, you can look up here or you can erase and rewrite. R, S, and T are still midpoints. This time, RH is 7, our S is 6, and we're trying to find ST. Got it, Zach? Why? Good. GH would have to be 14. 7 plus 7. And then ST is going to be half of that, so half of 14 is just 7. See that, Micah? Why are you weren't even looking? Okay, the next one deals with angles here. This is a little bigger for us. R, S, and T are still midpoints. Angle G is 60 degrees. Angle I is 70 degrees. And we're trying to find GTR. Gracie? Why would you do that? Which ones are congruent? Like the two little triangles are congruent? Is that what you're telling me? Why would you say the two little triangles are congruent? Oh. We gotta be careful, like, this side is marked congruent to this side, but these two sides aren't congruent. You see, this guy's got 2 and this one's got 3. You know what I'm saying? Okay. Lindsay, you got something? But the rule says that if the lines are parallel, then corresponding angles are congruent. Why? It's a midsegment. RT is a midsegment, and the theorem on the front says that a midsegment's parallel to the third side. So yes, RT is parallel to HI. If I use this bottom segment as my transversal, then 70 corresponds with GTR. So yeah, they'd have to be congruent. So GTR is 70 degrees. Good job. Ooh, green on green. Nice. Next one. R, S, and T are midpoints still. This time, angle H, this is poor writing on my part, the whole angle is 50 degrees. Angle I is 66 degrees. We're trying to find ITS. I feel like ITS is like the abbreviation for like tech people, isn't it? Internal Tech Services? They're pretty. I can't even get my phone to work unless I'm standing by my window. Spence. You have to give me a reason why. Does it say it's bisecting it? Then I don't know. It kind of says that. Well, T is the midpoint, but does that mean the whole segment's cutting it in half then? Sam? Okay. Like this? And that'd be 64? Do you guys agree with him? Good, you should. 50 corresponds down here, and then you have a tiny triangle, and you can use your triangle sum theorem. Anybody find angle G? Yeah, you could do the big triangle, 66, 50, and find this one, and then this one would correspond with this one also. There's a bunch of corresponding angles in these. Sometimes you have to find angle measures that you're not even really using, you're not marked. Remember that for your homework. Last one. The measure of G equals the measure of H, which equals the measure of I. So when angles all have the same measure, what do we say about them? They're all congruent. Oh, So it's what kind of a triangle?
Equal.
Equal angular, equilateral. If RT is 15,